Good morning to all. In today's session, I am going to discuss about one more sorting mechanism or one more sorting algorithm, which is called as the selection sort. In the previous sessions, we have started our discussion on the sorting mechanisms. We have seen what are different, what do you mean by sorting, and what are the various sorting algorithms we are going to study, and we have seen one more example on the bubble sort. So, our today's topic will be completely on the selection sort. As we have done earlier, we will start our discussion with the basic idea behind the selection sort, or we can also say that what is the procedure behind the selection sort, and then we will illustrate the same with one example. It is not the programming example. We will see, we will take some list of elements and we will try to implement the selection sort on those list of elements. Coming to our discussion on the selection sort, this is something we need to give some importance, where the given list of elements, whatever list of elements you are given, you are going to divide it into two groups. One is the sorted group and the second one is the unsorted group. So, the initial list of elements what you will take will be under the unsorted group. That even you write, when you write the program on the selection sort, you will take an array of size some n and you will prompt the user to enter those many elements, and the user is assumed to have or assumed to give the unsorted list of elements, and then you will apply this selection sort procedure. I will tell you the procedure, and the final result of the algorithm will be a sorted list of elements. So, basically whatever list of elements the user inputs for this program will be under unsorted group, and when you implement the program or the selection sort algorithm on this unsorted group, you will end up in dividing the given list into two parts. The same list you will be dividing it in two parts. One part will be consisting of the unsorted group of elements and the other part will be consisting of the sorted group of elements. We will see how it happens. And now, our topic of interest is the procedure or the basic idea behind the selection sort. Very important, as we have mentioned earlier in the earlier sessions, the basic idea behind any of the sorting algorithm will be very important, will play a very important role in implementing the algorithm. Now, the basic idea behind the selection sort is, the name itself is saying that we are going to select something. That is the reason why this sorting algorithm has been named as selection sort. So, we are going to select one element and we will apply the things, right. So, what element you are going to select here is, you are going to select the best element. What is this best element? Means the best element can be either the minimum element in the given list of elements, or it can be the maximum element in the given list of elements. So, the best element can be either minimum element of the list or the maximum element of the list. After selecting the minimum element or the maximum element, we will select only one part, either the minimum or the maximum. The choice belongs to the programmer. The programmer is free to select any of these elements, and once the element, the best element has been selected, you have to throw the best element to one end of the array. For example, the array will be like this, we know this one. This is called as the left end and this is called as the right end. And assume that you are taking the order as the ascending order. So, when you consider the ascending order, you know very well that the left side part of the array should be minimum. So, when you go like this from left to right, you are going from minimum to maximum. So, when you are given a list of elements, when you select the minimum element, so the minimum element should be to the left of the array. So, you have to throw the element. For example, if you find the minimum element at this location, what you will do is you will throw this element to the left part if it is minimum, this one. You take the reverse case, the same ascending order case, where you are selecting the best element as the maximum element. Now, you take the same this third element as the maximum element. Now, you have to throw the maximum element to the right end to this location, and this process should be repeated until all the elements get sorted. So, this is the procedure we have. The procedure or the basic idea behind the selection sort, once again I am repeating, is to select the best element, either the smallest or the minimum element or the maximum element from the unsorted group, and you have to throw that or put, you can anything you can say, or you can swap also. You have to swap that element or you have to put that element either towards the left end or either towards the right end. In general, we will call it as end of the sorted group. So, you will throw it to one end, and as I told that we have to repeat this process of identifying the best element and throwing it to one end until the unsorted group becomes empty. So, once you start processing this sorting algorithm, the unsorted elements or unsorted list of elements will be reduced for each and every step, and the sorted list will be increased. So, this process has to be repeated until all the elements get sorted. This is the basic idea, very important. And now, let us go through the example part. This is the example which I am going to consider here. I have 6 different elements. This is the array, and you know that this is the index number. The array index always starts with 0 and ends with n minus 1. So, I have the array index ranging from 0 to 5 in this particular scenario, and the user has given 6 different elements in unsorted order: 5, 1, 3, 4, 6 and 2. And remember that we are always considering the sorting mechanism as ascending order. We are taking the order as ascending order, that means from lowest to highest. So, while selecting the ascending order, the first step is, or the basic procedure is, select the best element. So, in this case, I am taking the best element as the largest element. And once you select the largest element or the best element, you put it at the right end of the array. Right. So, let us see how we are going to find the largest element. We have a program in the C programming language to identify the minimum element or the maximum element in the array. How this is done? Let us check, right. So, let me take a variable called high. You can the name can be anything of the programmer's choice. I am taking this as the high, and I will assign the first element of the array, whatever element it is there, I will assign it to the high variable. So, it becomes a of 0. The a of 0 is having the element as 5. So, my first element, whatever element I have taken high, the value I have taken is 5. Now, I will start comparing this high value with the remaining elements. So, 5 compared with 1. Since 1 is less than 5, you will keep the value of high as it is. Now, you will increment it, increment the pointer, and you compare 5 with 3. In this case also the 3 is less than 5. So, you just retain the value of high as 5. Now, compare the value of high with a of 3, that is 4. Since 4 is less than 5, you retain the value of high. Now, you increment the pointer. So, you are going to compare the high value with a of 4. Here you can see that the a of 4 value, that is 6, is greater than 5. Now, what you have to do is you have to replace the value of high with the a of 4, which is largest value 6. This process has to be repeated until the end of the array. You should not stop here. For example, if you have the element 20 here, now at the end of the processing, the largest element should be 20, right. So, the comparison part should be repeated until you reach the end of the array. Now, my high value is 6, then again repeat the process, compare 6 with the next element, that is a of 5. A of 5 is 2. Since 2 is less than 6, you retain the value of high as 6 itself. Since you have reached the end of the array, whatever value you have in this high variable will be the largest element in the array. The procedure remains same to find the minimum element in the array. So, here I will take the variable as low, and you assign the first value a of 0 here, which is equal to 5. Compare this low value with next element, that is 1. Since 1 is less than 5, you are maintaining the lowest value, right. So, you have to replace this 5 with 1. Now, repeat the process until you reach the end. Now, 1 compared with a of 2, which is 3. Since 3 is greater than 1, retain the value of low. Compare the value of low with a of 3. Since 4 is greater than 1, retain the value of low. Again increment the pointer, 6 compared with 1 greater than, so retain the value of low, and then the last element 1 compared with a of 5, that is 2. Since 2 greater than 1, you retain the value. So, the lowest value you have at the end of the processing will be 1. Either thing you can do, either you select the minimum or you select the maximum. The process remains the same, but you just have to change the programming part from greater than and less than, that is it. Forget about this low value, we are going to concentrate on finding the best element, that is the largest element. Once you find the largest element, the high value as 6. You have to swap the largest element with the rightmost element of the unsorted array. So, initially you will take the entire list as unsorted array. So, you swap this 6 and 2. Now, here it becomes 2 and here it becomes 6. So, at this part you can see that this entire left part from 5 to 6, this is unsorted array, and the last element we have is the sorted array. So, the process has to be repeated on the unsorted array, and at the end you will get the result as the sorted list of elements. So, let us see how it happens. So, this is my first element which I have taken it as the high value. 5 compared with 1, since 5 is greater than 1, you retain the value of high. Again 5 compared with 3, since 3 is less than 5, retain the value of high as 5. 5 compared with 4, since 4 is less than 5, retain the value as 5. Now, compare the value of 5 with 6. Now, what you have to do? You have to change the value of high to 6, the last element. Now, compare 6 with 2. Why? Because I have the high value as 6. Initially, high value will be 5, and when you compare this, you will get 6. 6 compared with 2, the high value will be retained as 6. So, the largest element will be 6. What you have to do? You have to swap this largest element with the last element. Why? Because you have to put the largest element as the rightmost element. So, this is what happens here. You are going to swap these two elements. Now, you can see here 5, 1, 3, 4, 2. This will be the unsorted array and this will be the sorted array. So, in the starting of the session, we have seen that the list of elements will be divided into two parts, unsorted array and sorted array. Initially, you will have all the elements in the unsorted array, and when you keep on implementing the selection sort, you will get the increments in the sorted list and the unsorted array will be decremented. So, this is what happens here, right. So, this is fixed, this will be the sorted list. So, this will be the sorted list, the 6 will be, and the remaining things will be unsorted list. Now, you will repeat the process on the unsorted array only. So, you will consider the 5 elements. Again, I will take the high value as 5, compare 5 with 1, retain the value of high as 5, compare 5 with 3, retain the value of high as 5, compare 5 with 4, retain the value of high as 5, compare 5 with 2, retain the value of high as 5. So, the largest element will be 5. You have to swap the largest element with the last element of the unsorted array. Here the last element is 2. So, you will swap these two elements. After swapping, this 5 and 6 will become the sorted array, and 2, 1, 3, 4 this will be unsorted array. Apply the same procedure of finding the maximum element from the unsorted array and swapping it with the last element. This is what happens. Now, when I start the process in the third iteration, the high value is taken as 2. That is, A of 0 will be taking in all the cases. So, it becomes 2. 2 compared with 1, retain the value of high as 2. Now, 2 compared with 3. Since 3 is greater than 2, the high will be exchanged or it will be replaced from 2 to 3. Now, compare the 3 with the next element 4. So, what happens? Since 4 is greater than 3, the high value will be replaced with 4. You have reached the end of the array, therefore, the largest element will be 4. Now, what you have to do? You have to swap the largest element with the last element of the unsorted array. Here you can see a special case where the largest element is 4 and the last element is also 4, last element of the unsorted array. So, you have to swap 4 with 4. This is nothing but you just place 4 like that only, no changes. Once you have done the swapping of the largest element with the last element, the last 3 elements becomes the sorted array and the unsorted array is from this part here to here. Again repeat the process on the high value on the unsorted array. Take the high value as the initial value, that is A of 0, that is 2. 2 compared with 1, retain the value of 2. Now, 2 compared with 3, therefore, high value becomes 3. You have reached the end of the array. So, the highest value or the largest value is 3 and the last element, the rightmost element of the unsorted array is 3 again. You swap these 2 elements. So, 3 swapped with 3 retains the same. After this, you have this 3, 4, 5, 6 under the sorted array and 2 and 1 under unsorted array. Repeat the process on this unsorted array. Select the high value as A of 0, that is 2. 2 compared with 1, retain the value of high, the largest value is 2. Swap this largest value with the last value or the rightmost value of the unsorted array, this one. Now, you can see that all the elements are in the sorted order. So, this is how the selection sort will work. I am once again repeating the process what we have done, just repeating the procedure or the basic idea. The basic idea or the procedure for the selection sort is you have to select the best element. The best element can be either the minimum or the maximum element from the unsorted list of array, and once you find the best element, you have to swap it with the last element, either from the left end of the array or from the right end of the array. It depends on what you are going to implement. Whether you are following the ascending order, that also influences the swapping of the element or the selected element with either the right or the left. So, if you select the ascending order and if you are going to select the best element as minimum, swap that minimum element with the leftmost part or leftmost element of the array. And if your procedure is ascending, let me write it here. When you select the ascending order, there are 2 different cases. Either you can select the minimum element or you can select the maximum element. If you select the minimum element, you throw that minimum element to the left end of the array. And if you throw the maximum element, you swap it with the rightmost element of unsorted array. But if you select the order as the descending order, here also you will get 2 different cases. but the process will be in the reverse order. So, if you select the minimum element as the best element, you have to swap it with the rightmost element of the array. And if you select the maximum element, since your order is descending order, you will be putting it or you will be swapping it with the leftmost element of the unsorted array. So, these two things you have to remember and you have to do the things. So, that is all for today's session. This is the end of the selection sort. Thank you one and all for joining the session.